Okay, in this second video of this short crash course about trigonometry, we continue with something that we call the unit circle that will help us a lot solving all these, evaluating all of these trigonometric functions at these angles that we said that are going to be multiples of pi over 4, pi over 6, and pi over 3. Okay, so what is the unit circle? The unit circle is just a circle with radius 1, right? As you can see, the radius here, it's 1. So these are the point 1, 0 on the x-axis. Zero, 1, negative 1, 0, and 0 and negative 1. Okay, so what will happen if I just, the radius is everywhere is going to be 1, right? So let's say I want to know what are the coordinates of this point, and I want to bring this somehow into I want to bring this into connection with this angle here, theta. Okay, so this point obviously has some coordinates x and y. Okay, what does x refer to? Well, x refers to this distance here. It's just the x distance, and this is going to be the y distance, right? The y length, which is the same thing as this one right here. So let us concentrate on this triangle right here. We don't know how much are x and y, but let's say that we know how much is theta, and we know how much is the hypotenuse. This is the right angle, right? We know how much is hypotenuse because we are talking about the unit circle, so the hypotenuse is 1. Okay, so now going back to the previous question, what did we say? What is sine of theta? Sine of theta is the opposite side. I'm concentrating on this triangle, the opposite side, which is y, and that's the length, right, over the hypotenuse, which is 1. Y over 1 is y. What is cosine of theta? Cosine of theta is going to be the adjacent side, right? And in our case, that length is x over the hypotenuse 1. That's equal to x. Which means that these coordinates here, x and y, interpreting them in terms of the length from the distance from the origin is just the length x and the and the length y. But in the unit circle, with respect to the angle theta, can be written as how much is x? Cosine theta and sine theta. Okay, so that means that every point on this unit circle can be described as cosine theta for x and sine theta for y. So remember that sine of theta is y and cosine of theta is x. So far, what do we know just by looking at this unit circle? Well, let's start when theta is equal to 0. How much is cosine of 0? Well, cosine of 0, right? This is the angle. This is the point where the unit circle intersects the x-axis, and that point is 1, 0. So cosine is the x coordinate of that point. Cosine of 0 is 1. Sine of 0 is 0. Now let's go to pi over 2 in radians. It's 90 degrees, right? How much is cosine of pi over 2? Well, when I look at pi over 2, that's this angle right here, I'm looking at the point 0, 1. So cosine of pi over 2 is equal to the x value, the x coordinate of that point, that's 0. Sine of pi over 2 is the y coordinate of that point, and that's 1. Now if we go to the angle pi, which is 180 degrees, how much is going to be cosine of pi? Cosine of pi is -1. Why? Because cosine of theta is the x-coordinate of that point. So cosine of pi is the x-coordinate of the point -1, 0. The x-coordinate is -1, so cosine of pi is -1. Sine of pi is equal to 0. And by the same logic, I'll let you figure out how much is cosine of 3 pi over 2. That's 270 degrees. Should get 0. And sine of 3 pi over 2 is equal to -1. Of course, if you do a full circle, the angle 2 pi or 360 degrees brings you back to the point 1, 0. So cosine of 2 pi is equal to 1, and sine of 2 pi is equal to 0. And once you know sine and cosine of these angles, 0, pi over 2, pi, 3 pi over 2, and 2 pi, you know the values of these angles. The values of the other trigonometric functions evaluated at these angles. For example, tangent of 0 is equal to sine of 0 over cosine of 0. Sine of 0 is 0 over 1 is equal to 0. On the other hand, cotangent of 0, which is cosine of 0 over sine of 0, is equal to cosine of 0 is 1 over 0. As we can see, cosine of 0 does not exist. Sorry, cotangent of 0 does not exist. It's undefined. Why? Because we cannot divide by 0. Similarly, tangent of pi over 2, well, by definition, tangent is sine of pi over 2 over cosine of pi over 2. Sine of pi over 2 is 1. Cosine of pi over 2 is 0. That means that tangent of pi over 2 does not exist, is not defined. And you can look at cotangent of pi over 2 is equal to, by the same logic, cosine of pi over 2, which is 0, over sine of pi over 2, which is 1. This is equal to 0. Okay, so that's how we find. You can talk about secant and cosecant and so on and so on. But now we're interested in these values here, okay, where cotangent does not exist, okay? The value pi over 2 for the function tangent of pi over 2, because that one does not exist. And because we talk about limits, we want to know what is going on there, okay? So very natural question is, what is the limit of tangent of theta as theta approaches to pi over 2? Okay? So let's solve this question. Limit of tangent of theta as theta approaches to pi over 2 is equal to the limit of sine of theta over cosine of theta as theta approaches to pi over 2, which is equal to sine of theta is 1, right? So I get a limit of 1 over cosine of theta as theta approaches to pi over 2. And what is the problem? The problem is that when theta approaches to pi over 2, cosine of theta goes to 0, so a constant divided by something that approaches to 0 goes to infinity. Now we have to check whether it's positive or negative infinity. But now look at this. Where is the difficult problem? As theta approaches to pi over 2, let's say theta increases from 0, goes towards pi over 2, okay? All of these values in the first quadrant, right? Cosine of theta will be positive. It will approach to 0, right? It will approach to 0. Look at the x. Look at the x value for each of these points, right? The x value is going smaller and smaller, it becomes smaller and smaller, and eventually is going to get 0, right? But all the x's are positive here. If I approach pi over 2 from the right side, although that might be a little bit more misleading, because when I'm talking about the unit circle, actually I'm going to approach pi over 2 from the, well, I'm going to approach from the right side, but it looks here that I'm approaching from the left side. As theta approaches to pi over 2, okay, cosine of theta is going to be negative. Why? Because all the x values here are negative. That can be easily seen if you simply sketch the graph of cosine of theta. And we've talked about this, okay? So this is pi over 2, this is pi, this is 3 pi over 2, and so on and so on. This is 1, and this is negative 1, 1 and 1, okay? So the graph of cosine of theta is this one. When it's cosine of 0 is 1, cosine of pi over 2 is 0, cosine of pi is negative 1, cosine of 3 pi over 2 is 0, and so on and so on. So the graph is like this. This is cosine of theta, and this is pi over 2. This is pi, this is 3 pi over 2. Obviously, when I'm approaching pi over 2 from the left, cosine of theta goes to 0, but all of these values are positive. When I'm approaching from the right, cosine of theta goes to 0, but all of these values are negative, right? Which means that in order to evaluate this limit, first I have to decide whether I'm going to evaluate it from the left or from the right. So pi over 2 from the left, let's say 1 over cosine of theta is equal to, so when I'm approaching from the left, or that means for values of theta that are less than pi over 2, this ratio will blow up to infinity, okay, because cosine of theta shrinks to 0. And for all the values of theta that are less than pi over 2, cosine of theta is positive. So positive divided by positive is positive infinity. Limit as theta goes to pi over 2 from the right, 1 over cosine of theta is equal to cosine of theta shrinks to 0 as theta approaches to pi over 2. That means that this ratio will blow up to infinity, but as theta approaches to pi over 2, but it's actually greater than pi over 2, right? From the right hand side, right, all of these values are negative. So positive divided by negative is negative infinity, okay? That's why we cannot talk about the limit of tangent of theta as theta approaches to pi over 2. If I am approaching from pi over 2 from the left, then tangent of theta will go to positive infinity. If I am approaching to pi over 2 from the right, then tangent of theta will go to negative infinity. Now we can do a few exercises like this. Let's say I want to evaluate what is the limit of secant of theta as theta approaches to 3 pi over 2 from the left, okay? Well, right away you can express secant through either sine or cosine. Secant is the reciprocal of cosine, so limit of 1 over cosine of theta as theta approaches to 3 pi over 2 from the left, okay? At 3 pi over 2, that's this angle 270 degrees, the x value that stands for cosine of theta is 0, so that means that the denominator goes to 0, constant divided by something that shrinks to 0 is infinity. Now as the denominator goes to 0, we have to determine whether that's positive or negative. So again, what does it mean theta going to 3 pi over 2 from the left? That means that it approaches to 3 pi over 2 from the side where the values are less than 3 pi over 2. So that means we are approaching from here. Okay? And as you can see, in this quadrant, all the values of cosine are negative. So positive divided by negative is negative infinity. Of course, the same can be seen from the graph of cosine of theta. If I'm approaching 3 pi over 2 from the left, indeed cosine of theta will go to 0. This graph approaches to 0, but all of these values are negative. So I get negative infinity. Okay? What would be the limit of cotangent of theta as theta approaches to 2 pi from the right? This is equal to the limit of cosine of theta over sine of theta as theta approaches to 2 pi from the right. 2 pi, it's this angle right here, so the point is 1, 0, x is 1, y is 0. That means cosine of 2 pi is 1, sine of 2 pi is 0, which means that the numerator approaches to 1, the denominator approaches to 0, and this limit again is going to go to infinity. Now we have to determine whether it's positive or negative. The numerator is 1, positive 1, so everything depends on the denominator. Okay, so now I'm approaching 2 pi, theta is approaching 2 pi, but from the right. That means that all the values of theta are actually greater than 2 pi. So that means that we're approaching from here for angles that are greater than 2 pi. In this quadrant, the y value is positive, sine of theta is positive. That means that sine of this limit here will approach 0, but from the right. So positive divided by positive is positive infinity. Of course, you can, if you know the graph of sine of theta, and we have done this already, so 1, 1, 2, 3, 4, and so on and so on. These values are a negative pi over 2, pi over 2, pi, 3 pi over 2, 2 pi. And here let's say 1 and negative 1. This is the graph sine of theta. Y is equal to sine of theta. This is theta. This is y. Okay. So as theta is approaching to 2 pi from the right, the graph of sine of theta indeed approaches to 0. The value of sine of theta approaches to 0, but from the right. Okay. All these values are getting smaller and smaller, but are positive. That's how we get positive infinity. Okay, so in this video we have covered the values of the trigonometric functions of the angle 0 pi over 2, 3 pi over 2, pi, 2 pi over 2, 2 pi, and so on and so on. In the next video we will still use the unit circle, but in that case we'll talk about the multiples of the angles pi over 4, pi over 3, and pi over 6.